kids, we're trying to do a pretty quick ed puzzle about inclined planes, acceleration and friction. And my first question is, if you were trying to calculate this angle and you had a meter stick, how could you do it? That's right, you just use trigonometry. So I'm going to do some trig for you, okay? If you look on top of this ramp, it's a ramp we've used before. We're going to let the objects go for 1.5 meters. So that's going to be our hypotenuse. And I can tell you that this side is 42 centimeters high, 42 to the ramp where the weight will be sitting. So if we have 42 here, and the hypotenuse is 1.5 meters, so 150 and 42, what trig function should you use? Should you use sine, cosine, or tangent? That's right, you should definitely use tangent. Now what I want to do with, excuse me, sorry kids, you should definitely use sine, all right? Because this is the angle, and this is the opposite side, and this is the hypotenuse. So first of all, let's calculate the sine. Let's find the angle. The sine is going to be equal to 0.42 over 1.5. So we're going to pause that. I'm going to calculate it. So I did 0.42 divided by 1.5, and then I hit second sine on my calculator, and that gave me this angle of what? What do you get when you do that? That's right. 16 degrees or 16.26 degrees, something like that. That's good. Now here's what I want you to do. Tell me, what should the acceleration down a 16-degree hill be? What should the acceleration of an object like a ball that we'll consider frictionless, what should it accelerate down the hill with? We know this is 9.8 meters per second squared. So on a 16-degree hill, what should that be? Exactly right. Let's go ahead and calculate it together. We'll say 16 degrees, right? 16 degrees is our hill. So the sine of 16 times 9.8, we should see an acceleration of 2.7 meters per second, all right? So we're going to pause it again and set up. So now we're going to take a look at this weight. And this weight has friction against the ramp, okay? So it's not going to slide at 2.7 meters per second. It's going to have friction. So we're going to calculate its actual acceleration, okay? So if we know the distance and we can time how long it takes to go that far, then we can very, very simply use one simple shortcut formula. What is the shortcut formula to find acceleration if you know distance and time? And that is right. It is xf equals 1/2 at squared. So what we're going to do is I'm going to slide this, and you at home, you're going to time it, okay? And you can play this over and over, and you're going to solve it. I'm giving you no more information. It's sliding 1.5 meters. You can time it. Ready? 3, 2, 1, go. All right. Pause it for a second. So what time did you get? All right. We got 3.2 seconds here, and we tried it a couple of times. So if you know it's 3.2 seconds, what was the actual acceleration of this weight down the ramp? Pause it. Here's our weight. And this bad boy slid down the ramp with friction and went a total of 1.5 meters. So 1.5 meters is how far we went. And that's going to be equal to 1/2 that A that we're looking for. We're trying to find the acceleration down the ramp. And it took it 3.2 seconds to do that. So if we solve this, I'm going to take the 1/2 over here. And I'm going to skip down here now, kids. So that gives us 3 is equal to A times 3.2 squared. Or in other words, 3 divided by 3.2 squared. And that gives us an acceleration is equal to 0.29 meters per second per second. And that is much, much lower than the frictionless tennis ball, right? Let's think about this. The frictionless tennis ball, when it rolled down the ramp had a 16.26 degree angle. So the frictionless tennis ball, it just rolled down the ramp with the sine of 16 times 9.8, right? So anything without friction will go down the ramp at 2.77 meters per second every second. But our weight only went down the ramp accelerating at 0.29 meters per second per second. So how could we take all of this information and calculate the friction of the weight against the ramp? This is how we can do it. The actual acceleration down the ramp is equal to, and this is a formula that you're just going to have to learn, gravity times the sine of the angle minus gravity times the cosine of the angle times friction. And that gives us our actual acceleration down the ramp was 0.29 meters per second per second. Gravity times the sine of the angle, that's the very beginning of the problem. That was 2.77 meters per second per second. That's the frictionless acceleration. But we're also being slowed down by gravity times the cosine of the angle times mu. Now gravity times the cosine of that angle, 16.26 cosine times gravity, 9.8, is equal to 9.4 or 9.41. And now we've got to solve for this mu. Now kids, this is algebra 1. All of these units are the same, so you can add them, subtract them how you need, and solve for this mu. So I'm going to ask you to solve for the mu at home. Okay? Keep it rolling. So let's solve for the mu right now together. I've already asked you what this was. This is how we would do it. We've got to solve for this mu over here. This says minus 9.41 mu, so I'm going to put it over here as 9.41 mu. That's 8th grade algebra 1, okay? Now we have 2.77 meters per second here. I'm going to take the 0.29 and say minus 0.29 meters per second, all right? So 2.77 minus 0.29 equals 2.48 meters per second. Now we have to get the mu by itself. This is 9.41 times mu divided by 9.41 over here, divided by 9.41, gives us a mu, just like we had calculated on our own, of 0.26. And there are no numbers for the mu. That is a frictionless, that is a unitless number. It is scalar. And we're going to give you one problem to work like this. And it will be exactly like this. All right? And you should be able to do it by going back and watching this.